Hi everyone. Let's go over the operations with rational numbers today. What are fractions? Fractions are another way of thinking about division. So for example, 1 divided by 2 is the same thing as 1 over 2 in fraction form. How do we multiply fractions? We multiply the numerators together and then denominators together. For example, 2 over 3 times 3 over 4 equals. By the way, just a recap, the top number here is called numerator, and the bottom number here is denominator. Okay, so we want to multiply the numerators together, so 2 times 3 on top. We keep the division sign here, and 3 times 4 on the bottom. 2 times 3 is 6. 3 times 4 is 12. We could reduce this further by dividing both top and bottom by, both top and bottom by 6. So we have 1, 2. So this equals to 1 over 2. How do we divide fractions? We can change the division sign into multiplication first. And then we're going to find the reciprocal of a second fraction. Example, 2 over 3 divided by 3 over 4. So we're going to change the division sign into multiplication sign first. So let's do this equals to 2 over 3 and switch it to the multiplication sign. And then we're going to find the reciprocal. Reciprocal is when the fraction flips top and bottom. So numerator becomes denominator and denominator becomes a numerator. For example, reciprocal of 1 over 2 is 2 over 1, which is equivalent to 2. Okay, so we are flipping the top and the bottom. That's reciprocal. So we're only reciprocating the second fraction, which is this one, the second one. So we'll do multiply 4 over 3. And again, we're going back to multiplying fractions. So numerators together. So 2 times 4. Keep the division sign. And 3 times 3. So denominators are together. 2 times 4 is 8. 3 times 3 is 9. It looks like we cannot go any further or simplify any further, so we'll keep it here. How do you figure out whether two fractions are equivalent? So now we're going to compare two fractions. We need to get the denominator to be the same, as in we're looking for common denominator by multiplying the entire fraction by common factor. Multiplying common factor. And if you cannot think of a common factor, you can multiply the entire fraction by the other denominator. So let's take a look at the first question here. Are 2 over 3 and 5 over 6 the same? First of all, we have to compare the denominator, and they're different. One is 3 and one 6. So we need to multiply the entire fraction by a common factor. What they mean by that is, if you look at 6, we know 6 is a multiple of 3. Okay, so 3 times 2 is 6. So I'm just going to change the first fraction in terms of the denominator 6. So if you multiply the bottom by 2, then you're supposed to multiply the top by 2 to balance the fraction. We're going to rewrite that first fraction. So 2 times 2 is 4. 3 times 2 is 6. So this converts to this. we're saying, is 4 over 6 equal to 5 over 6? The answer is no, they're not the same. How about the next one? Are 2 over 3 and 5 over 7 the same? This time, unfortunately, these two numbers are two prime numbers, so we know that they're not multiple of each other. So we have to just multiply the entire fraction by the other denominator. As in, for the first fraction, we want to multiply the entire fraction by 7. For the second one, we want to multiply by 3. You're multiplying the entire fraction by the other denominator value. So whatever you multiply on the bottom, you do the same for the top. Multiply by 7, multiply by 3. So the first fraction becomes 14 over 21, and the second one becomes 15 divided by 21. So now we have a common denominator, and we know that these two fractions are not equivalent. So no. Lastly, how do we add or subtract fractions? First, make sure the two fractions have common denominator. Okay, once they have the same denominator, you can add or subtract the numerator, only if they have one already. If not, you have to rewrite it in terms of the common denominator. Okay, so let's take a look at the example. 2 over 4 minus 3 over 4. First thing you need to check is the denominator, and they're equal, thankfully, so we can just subtract the numerators only. So 2 minus 3 all over 4. Okay, so this equals to negative 1 over 4. Next example, 2 over 3 plus 3 over 4. This time, we know that the denominators are not equal, so we need to find a common denominator. It looks like 3 is not a multiple of 4, and 4 is not a multiple of 3, so might as well just multiply the entire fraction by the other denominator. So the first fraction can be multiplied by 4. Second fraction can be multiplied by 3. So whatever you do on the bottom, you do the same on the top. And so let's rewrite this. This equals to 8 over 12 plus 9 over 12. Now, because we have a common denominator, we can just add the numerators together. So 8 plus 9 all over 12, which equals to 17 over 12. If you like mixed number, you can simplify this further. So 1 and 5 over 12. But honestly, this form is perfectly fine. So how do you convert mixed number into improper fraction? Multiply the denominator by the whole number in the front. So here, let's do that one at a time. So multiply the denominator by the whole number in the front, 2, and then add the numerator, like that. So keep the denominator the same. So let's take this and say we keep the denominator 3 first. So you write that first just in case you forget that they're the same. So 3 times 2. So I go with 3 times 2. And then you're going to add numerator at the end. So this one is equivalent to saying 6 plus 1, because 2 times 3 is 6. We have 7 over 3. So that's how you convert to improper fraction. Okay, I kind of went over quickly previous example, but this is just a step-by-step instruction. All right, so how do you convert improper fraction to mixed number? So we have to first check how many times denominator goes into numerator. I said n times here, but that just means like how many times, like 3 times, 4 times, 5 times, and so on. Remove the product of denominator and n from the numerator. Okay, we'll give you, and keep the leftover on the numerator. So let's just go straight into our example here. So we have 11 over 4, and 4 goes into 11 how many times? 2 times. So 4 times 2 is 8. Okay, so look at that. We talked about how many times does the denominator goes into numerator? 2 times. And then we said the product of the denominator and n right here, and keep the leftover on the numerator. So this one, next step would be 11 minus 8, which is 3. This is same thing as 2 and 3/4. All right, we're moving on to order of operations. We also call it BEDMAS. Yep. All right. Okay, so please recall back that BEDMAS stands for the order of operation, as in bracket first, exponent next, division, and then multiplication, addition, subtraction. So the order goes top to bottom. And just something to remember is that division and multiplication and these two as a pair, these two don't necessarily mean like division always first before multiplication. They could switch depending on which operation comes on the left-hand side first. Okay, so left to right, whatever that comes first among these two and among these two. Okay, so let's go straight into our example. 5 over 6 minus 1 over 3 times 3 over 4. First thing I would like to check is which operation we have. We have two operations here. One is subtraction and one is multiplication. We know that the multiplication comes before subtraction. Okay, so we're going to do this one first, and then we're going to do the rest. So let's take a look at this. We're going to solve this first. So we're going to bring down the rest of the equation first, minus. And recall back to how to multiply fractions together. So numerators together and denominators together. So 1 times 3 is 3 on the top. 3 times 4 is 12 on the bottom. Now, in order for us to subtract two fractions, we first need to check their denominator. And unfortunately, they don't have a common denominator. But we know that 12 is a multiple of 6. So we can just multiply 2 to 6. So whatever you do on the bottom, you do the top. And we're going to make this first fraction into denominator 12. And we bring down the rest of the equation. Okay, so this equals to, now that they have a common denominator, we can just subtract the numerators. So we have 10 minus 3 all over 12, which is 7 over 12. We cannot simplify this any further, so we'll leave it there. All right, part B. We have this equation or expression. We have two operations here. Notice that multiplication comes on the left-hand side first before division. So even if the division looks like it's before multiplication, if this one of these two happen on the left-hand side first, that's what we're going to work on first. Okay, so this time we have to work on our multiplication first. This one first. And in order for us to multiply a mixed number and a fraction, we first need to convert that mixed number into improper fraction. Okay, so the rule, we just went over how to convert the mixed number into improper fraction. We first multiply the denominator by the front number, and then we're going to add the numerator on top. And we keep the same denominator. Okay, so this one, if we rewrite it, it's going to be 2 on the bottom. 2 times 1 is 2. 2 plus 1 is 3. 3 over 2. We're going to copy down the rest of the expression, and then we're going to move from there. All right, so this first. So when you're multiplying two fractions, we don't have to check for a common denominator because we're just going to multiply the top together and the bottom together. Okay, so 3 times 1 is 3. I'm just going to, don't forget the equal sign. 2 times 3 is 6. And then we're going to bring down the rest of the equation divided by 2 over 3 on the side. Now, before you reduce anything, I mean, if you notice that this is just 1 over 2, that's great. But if you don't worry about it. We can always simplify at the end. When you're dividing two fractions, we switch the sign. So basically, let's just do that again. So we're going to keep the first fraction together. We're going to switch the division sign into multiplication sign, and we're going to flip the second fraction. Okay, we're going to reciprocate it. And now we're going to complete this by multiplying the numerators together. So 3 times 3 is 9. Denominators together, so 6 times 2 is 12. And we can actually reduce this further. So let's do this divided by 3, 4. All right, so we have 3 over 4 as our final answer. All right, part C. 3 over 4 times 12 minus 8 minus 3 over 8. Okay, so this time, let's take a look at the order of BEDMAS again. So it looks like we have operation multiplication, we have an operation here, but we also have a bracket here. So by order of operation, we have to work on our brackets first. So that means we have to work on this first, inside the bracket first. Okay, so let's rewrite the expression. 3 over 4 times. We know 12 minus 8 is 4, so we're just going to leave 4 in there. And we're going to bring down the rest of the expression, minus 3 over 8. All right, now we have two operations, and multiplication is on the left-hand side, and multiplication has a higher priority, so we have to do that first. So let's work on this first. Equals, and notice that 4 is technically a fraction as well. It's 4 over 1. So we can multiply the numerators together. So 3 times 4, which is 12, and 4 times 1 is 4. And bring down the rest of the expression. All right, so this one now, We don't have a common denominator, so we have to make it have one. We can say that 8 is a multiple of 4, so we multiply 2 to 4 to get an 8. This means we have 12 times 2 is 24, and 4 times 2 is 8. Bring down the rest, or write the rest again. And we can say 24 minus 3 is 21. Keep the denominator 8. You can convert this into a mixed number. It's totally up to you. Unless I instruct it, I don't suggest you do it. But if you were to do it, this would convert to, this is equivalent to 2 and 5 over 8 as a mixed number. Part D. 3 and 7 over 10 divided by all of 1 and 3 over 10 plus 1 and 9 over 10. Alrighty. So we see the bracket first, so we gotta work on the inside the bracket first. But in order for us to do it, either you can convert these mixed numbers into improper fraction first, or they have a common denominator, so maybe you can just like add them together as it is. So let's try that. We want to make sure we don't do extra step unless we have to. So let's take a look. 1 plus 1 is 2. So let's front two numbers here. We're going to keep the denominator. Denominator never changes when you're adding or subtracting. And also on the 3, on the top here, 3 and 9. So 9 plus 3 is 12. But notice that this portion is an improper fraction. So we have to rewrite this so that it's not an improper fraction. Okay, so let's rewrite this. How many 10s go into 12? Ones. So we're going to add that 1 into the whole number in the front. So we get 3 in the front. Common denominator 10, or not common, the same denominator 10, and we're left over with 2 on the top. You can simplify this further by dividing both top and bottom by 2. So we have 1 on the top, 5 on the bottom. We have 3 and 1 over 5 inside the bracket. Let's rewrite our expression. So 3 and 7 over 10 divided by 3 and 1 over 5. All right, so the problem with this is that we don't know how to divide two mixed numbers. Okay, so we need to convert this into improper fraction. Let's do that first. So we keep the denominator for the first fraction. We multiply the denominator and the whole number in the front, and then we add the numerator. Okay, so we have 10 times 3 is 30. 30 plus 7 is 37. Okay, divided by, we keep the 5, the denominator, and we go multiply 5 times 3, and then we add 1. So we get 16. Now we could apply that rule we learned in the other page. We can just rewrite this division sign into multiplication sign, and we can reciprocate the second fraction, just like this. Okay, and from Math 9, we should kind of know how to simplify before we multiply these big numbers. Perhaps we can divide, hold up. Yeah, so we can reduce this by 1 and 2. And 37 is unfortunately a prime number, so it won't be, reducible. So we'll just leave it at that. So we have 37 over 2 times 16 on the denominator, which ends up being 32 on the bottom. And again, you don't have to reduce this or rewrite this into a mixed number. But if you want to, it's going to be 1 and 5 over 32. So that's it for operations with rational numbers.